Hello and welcome to this episode of Math with Martinez. In today's video, we are going to be solving radical equations. And in order to do so, there are 4 different steps that we're going to be taking. So let's go ahead and get started with this first example. As we see here at the top of our page, the very first step is to isolate the radical on one side of the equation. That means that we want that square root all by itself. In example number 1, we don't have that square root by itself. We've got this 5 that's being added with it. So what do we need to do to undo that 5 that's being added? Yep, we will need to subtract 5 on each side, and that's then going to give us the square root of x equals 7. Now, we'll move on to the next step, which is to take and raise each side of the equation to the power of our index. Our index here is an understood 2, and so that means we're going to square each side to the second power. And let's go ahead and write what that would simplify to. That's just going to be x equals 49, because 7 squared is 49. And there's really no need for step number 3. This is the end of our solving process here. So what we want to do is we then want to go ahead and do the checking. We need to check and make sure that if I take and plug in 49 into my equation, it makes it true. The square root of 49 is in fact 7, and we're going to add 5 to that, and 7 and 5 is 12. 12 equals 12. So this checks out. Everything looks really good. Always check, because if you get something that is a false statement, then that is called an extraneous solution. It's a value that we found algebraically that actually is not one of our solutions. Let's go ahead and take a moment to look at our next example here together. What's going to need to be our first step in isolating our radical? What do we need to do to isolate our radical on that left side? Once again, we're going to be subtracting. We'll be subtracting 10 on each side. The result is that we will have the square root of a plus 7 equals just 1. Our next step is to raise each side of the equation to the power of our index. Well, this is a square root, which is the second root. So we're going to need to square both sides of this equation. And that gives us just a plus 7, since we have undone our root, and 1. Now we do have a step 3, which is to solve the remaining equation. I'll do that by subtracting 7 on each side, and that's going to give me a equals -6. That is the result. Now let's go ahead and see about checking our solution. Before we can say confidently that it is, let's check it and make sure that it makes our equation true. So into the original, I will plug that -6 and make sure that my left and right side equal each other. This is going to be just a square root of 1. The square root of 1 is 1, and 10 plus 1 is 11. All right, so that value makes it true. I can confidently say that is a solution. Now, what we've got here is something just a little bit different, and so I want to make you aware of what this little fraction exponent means. This means the same thing as taking the square, or that second root, because what is in the denominator is a 2. That would be a square root. Whereas this one right here, do you see how it's a 1/3? This means the same thing as taking a cube root. So when you have those little fractional, or what we call rational exponents, they're just another way of expressing your roots. So we can go ahead and begin to take the same steps, because we are dealing with a radical equation, even if our radical is a rational exponent. We're going to isolate that radical on the right-hand side. Right now, I have this 9 in front of that parentheses, so how will I undo that, ladies and gentlemen? To undo that multiplying, I must divide each side by -9. That's going to give us 4. And then on the other side, now I have my little expression nicely isolated. The next step is to raise each side of the equation to the power of our index. So what I have right now is c minus 12 to the 1/2 power. The opposite of that is raising it to the second power, because what happens when you raise 1/2, or when you multiply, think about this with me, when I multiply 1/2 times 2, what does that equal? It equals 1, so that will cancel my exponents on the right-hand side, and it'll simplify to 16 equals c minus 12. Well, let me do that in my black color. And then our final step is to go ahead and solve before we check. So then I'm going to add 12 on each side. And that gives us that c is equal to 28. 28. Now we just need to check and make sure that that does make our equation, the original one, true. So I'm going to plug that in right here. And let's begin to simplify. Inside, 28 minus the 12 is 16, and that's raised to the 1/2 power. Now, raising it to the 1/2 power is the same thing as taking the square root. So what is the square root of 16, ladies and gentlemen? It is 4. So we have -36, and the product of those two, -9 and 4, is also -36. So this is a solution. We can say that confidently since we've checked. One final example with you all today. Let's go ahead and get started like we've been doing, beginning with isolating the radical on one side of the equation. That's going to mean we'll do what, y'all? Because we're subtracting 9, I need to add 9 on each side. That's going to give us that the fourth root of 8k plus the 12 is equal to a -2. Then we will move on to the next step, which is to raise each side to the power of our index. Now this one was a fourth root, so we're going to raise it to the fourth power on each side. When I raise this left side to the fourth power, that leaves me with just the 8k plus the 12. And on the other side, negative 2 raised to the 4th power is 16. Now, step 3, solve the remaining equation. We will need to subtract 12 on each side. And that's going to give us a 4. HK equals 4. And then dividing by 8 on each side, we find that our value of K would be 1/2 when we simplify that fraction. So let's check it and make sure that that does make our equation true. I take the 4th root of 8 times 1/2 plus the 12. Then I'll subtract 9 from that, and it should give me a negative 11. Inside that radical, when I take half of 8, that's 4. 4 plus the 12. 4 plus the 12, we're taking the 4th root of that, subtracting 9, and it should be negative 11. I'm really taking the 4th root of the sum of those two, which is 16. And the 4th root of 16 is 2. Now 2 minus 9 is actually negative 7, which is not equal to negative 11. So ladies and gentlemen, there is actually, in this case, no solution. Because what we found, this 1/2, was actually an extraneous value. It's a value we found algebraically by following our rules, but it actually does not make our equation true, so it is not a solution. That's why it's so important to do step number 4 and always check. That's it for our video today. If you guys had any questions, would you please take a moment to share those now? And until next time, stay fired up, y'all.